Welcome to the Network Security Series. Today we're diving into the world of firewalls. In this session, we will learn about the types of firewalls, how to configure them, and how to implement rules effectively. Let's get started. So, what exactly is a firewall? A firewall is a network security device that meticulously watches and filters both incoming and outgoing network traffic. It acts like a gatekeeper, carefully examining each piece of data based on a set of predetermined security rules. Imagine it as a barrier between your trusted network and the untrusted outside world. It carefully inspects packet headers and contents and enforces access control policies, ensuring that only legitimate and safe traffic is allowed in and out. Let's explore the different types of firewalls available. First, we have packet filtering firewalls. These examine network packets in isolation, without considering the state of any connections. They inspect the source and destination Internet Protocol addresses, check port numbers, and operate in a stateless manner, requiring low resources. Second, we have stateful inspection firewalls. These monitor active connections and determine whether packets are legitimate based on the connection's current state. These maintain a state table and are more secure than packet filtering. This type is widely implemented. Finally, we have next-generation firewalls. These combine the capabilities of traditional firewalls with advanced features, allowing for deeper inspection of traffic. They offer deep packet inspection, application awareness, intrusion prevention, and user identity integration. Let's explore more types of firewalls. We have proxy firewalls, which act as an intermediary between end users and the websites they visit. This helps hide internal network details, provides application-level filtering, offers content caching, and enhances security. However, this comes at the cost of speed. We have host-based firewalls, which are software programs installed on individual devices to protect them from network threats. This protects individual endpoints, provides application-specific rules and portable protection. Examples include Windows Defender and IP tables. Finally, we have cloud firewalls, also known as Firewall as a Service. These are deployed in cloud environments to protect cloud resources. They offer scalable protection, eliminate the need for hardware maintenance, and provide centralized management. Examples include Amazon Web Services Network Firewall and Azure Firewall. Now let's take a look at different firewall architectures. First, we have the single-layer firewall. This is a basic setup with a single firewall positioned between the internal network and the Internet, offering basic protection. However, it creates a single point of failure. Second, we have the DMZ architecture. This creates a demilitarized zone between the internal and external networks. Public-facing servers are placed in the demilitarized zone for controlled access. Finally, we have the multi-layer defense. This architecture implements multiple firewalls using different technologies to create defense in depth, which provides redundancy and a stronger security posture. Let's look at some of the firewall configuration basics. First, we have default deny policy. This means you should block all traffic by default and only allow what is explicitly permitted. Second, we have least privilege. This means you should grant only the minimum access necessary for system to function properly. Documentation is also key. Make sure to maintain detailed records of all firewall rules, including their purpose and owner. Finally, regular review is important. Periodically audit and update firewall rules to remove unnecessary access. As a basic configuration example, we'll flush existing rules, set default policies to deny all, allow established connections, and allow secure shell from a specific network. Let's explore how to implement firewall rules effectively. Firewall rules consist of several key components that determine how traffic is filtered. These include the source and destination Internet Protocol addresses or ranges, the protocol, which can be Transmission Control Protocol, User Datagram Protocol, Internet Control Message Protocol, and so on, the ports, which are service-specific port numbers, the action, which can be to allow, deny, or log traffic, and the direction, which can be inbound or outbound. Understanding how rules are processed is crucial for effective firewall configuration. Order matters as rules are processed sequentially. First match means processing stops at the first matching rule. The default policy is applied if no rules match, so it is important to use rule optimization by placing common matches first. There are standard rule types implemented in most firewall configurations, such as ingress filtering to control incoming traffic, egress filtering to control outgoing traffic, network address translation rules, and application rules to provide Layer 7 filtering. When implementing firewall rules, it is important to be specific rather than general, to test before deployment, to document everything, to conduct regular audits, and to use change management to track all modifications. Let's look at a few examples of firewall rules. This Linux IP tables example details a basic web server configuration that allows Hypertext Transfer Protocol and Hypertext Transfer Protocol secure traffic. It also only allows secure shell from the admin network. The Windows Firewall example shows PowerShell commands to configure the Windows Defender firewall, creating an inbound rule for structured query language server, and blocking outbound file transfer protocol. Let's delve into firewall testing and troubleshooting. First, we'll set a testing methodology, consisting of the following. Baseline testing should document normal network behavior before implementing changes. Rule verification should test each rule individually to confirm expected behavior. Connectivity testing should verify both allowed and blocked traffic patterns. The performance impact should measure network performance before and after implementation, and security validation should attempt to bypass rules to identify weaknesses. Some useful troubleshooting tools include TCP dump and Wireshark, which are used to capture and analyze network packets to verify traffic flow. Network Mapper is used for port scanning to verify which ports are open or filtered. Telnet and Netcat are used to test specific transmission control protocol, and user datagram protocol connections to verify access. Ping and traceroute are used to verify basic connectivity and identify where traffic is blocked. Firewall logs are used to review log entries to understand rule matches and actions, and Hypertext Preprocessor 3 is used for advanced packet crafting for testing specific firewall rules. Let's wrap up by exploring firewall best practices and future trends. First, defense in depth means implementing multiple layers of security controls beyond just firewalls. Regular audits mean conducting periodic reviews of firewall rules to remove outdated configurations. Change management means implementing formal processes for firewall rule changes with approvals. Segmentation means using firewalls to create network segments based on security requirements, and backup configurations means maintaining backups of firewall configurations for disaster recovery. Some future trends include the following. Zero Trust architecture is moving beyond perimeter-based security to verify every access request. Artificial intelligence-powered firewalls are using machine learning to detect and respond to threats automatically. Cloud-native firewalls are purpose-built security solutions for cloud environments. Firewall as a service means subscription-based firewall solutions delivered from the cloud, and intent-based networking means automated policy implementation based on business requirements. Thank you for attending this session on firewalls. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.